Most people imagine a military base as a single thing, a fenced compound with barracks, runways, and armored vehicles moving in and out. In practice, the American military does not run on one standard kind of installation. It runs on a layered network of highly specialized sites, each built for a different function in the larger system of force generation, deployment, maintenance, intelligence, and deterrence. That distinction matters because the word base hides an enormous range of infrastructure. Some installations are effectively mid-sized cities, built to house entire divisions, training grounds, schools, hospitals, warehouses, and the families of service members. Others are narrow, highly technical facilities with one mission only: launch tracking, cyber operations, missile warning, munitions storage, or submarine support. Some exist to prepare forces for war. Others exist to sustain war from a distance. And some never appear in public imagination at all, despite being essential to how military power actually works. The common misconception is that combat capability begins with frontline troops. In reality, it begins with the architecture behind them. A paratrooper brigade cannot deploy without a post to train and organize it. A carrier strike group cannot sail without a naval station, a weapons pipeline, and industrial maintenance yards. A modern intelligence operation cannot function without secure campuses full of analysts, servers, and communication systems. What looks like one institution from the outside is actually a distributed machine. That machine is also shaped by geography. Coastal bases support fleets and amphibious forces. Inland forts concentrate ground combat power. Air bases organize mobility and air superiority. Remote radar sites extend awareness far beyond U.S. borders. Joint bases merge services for efficiency, while local guard facilities tie federal force structure to state emergencies. To understand what the U.S. military can do, it is not enough to count troops, ships, or aircraft. The real starting point is the basing system that houses them, moves them, repairs them, arms them, and connects them into one operational framework. To understand how military power is organized on the ground, it helps to start with the largest and most familiar installation type, the major service base. These are the command platforms people usually picture when they hear the word military base. But their real function is much broader than simply housing troops. For the Army, that role is centered on the post or fort. These installations are built to assemble combat power at scale. They combine barracks, family housing, maintenance yards, headquarters buildings, medical services, warehouses, training areas, and transportation links into one controlled system. A major Army post is not just a place where soldiers live. It is where brigades and divisions are formed, equipped, drilled, and prepared for deployment. The Marine Corps uses a similar model, often through large bases and camps designed around expeditionary ground forces. But marine infrastructure reflects a different operational logic. Because the Corps is structured around rapid deployment and amphibious warfare, many of its largest installations are positioned to support embarkation, levy, fire maneuver training, and close integration with aviation. That is why the relationship between a Marine base and a nearby air station is so important. One supports the ground force. The other sustains the aircraft that move it, protect it, and strike in support of it. This is where the first big structural divide appears. A base is not defined only by size. It is defined by mission. An Army installation may revolve around massing land combat units. A Marine installation may revolve around expeditionary readiness. On paper, both are simply places on a map. In practice, each is a tailored operating environment built around a specific doctrine. A well-known example is Fort Bragg, now Fort Liberty, which became synonymous with airborne force generation because the installation was built around that mission. And that points to the next layer of the system. Once ground forces are organized, they still depend on an entirely different category of base to project power at long range. Air power changes the meaning of a military installation. A ground base is built to organize and sustain people and equipment in place. An air base is built to generate sorties, move forces across continents, and keep aircraft ready under strict technical and logistical demands. It is less a simple station than a continuous production system for flight operations. That starts with the runway, but the runway is only the visible surface. Behind it sits a larger framework of hangars, maintenance complexes, fuel farms, munitions storage areas, air traffic control, weather units, security forces, and command centers. Every takeoff depends on a tightly sequenced chain of inspections, repairs, fueling, loading, and coordination. A modern fighter wing or air mobility wing cannot function unless that entire support structure works with industrial precision. Different air bases are built for different missions. Some are optimized for tactical aviation, supporting fighters, bombers, or intelligence aircraft. Others are mobility hubs, designed around cargo aircraft, aerial refueling, and rapid global transport. That difference shapes everything from runway length to warehouse capacity. A base built for strategic airlift has to handle oversized cargo, fast loading cycles, and a steady flow of personnel and equipment moving in and out. A base centered on combat aviation is more focused on sortie generation, weapons integration, and hardened support infrastructure. A useful example is Ramstein Air Base in Germany. Publicly, it is often described as a large overseas U.S. air base. Functionally, it is far more than that. It acts as a logistical relay point linking the continental United States to Europe, the Middle East, and Africa. Aircraft, cargo, medical evacuation, command functions, and allied coordination all intersect there, making it a node in a global network rather than an isolated installation. That is the key point. Air bases compress distance. They allow the military to shift from local presence to rapid reach. But aircraft alone do not sustain global power. Once forces and supplies begin moving across oceans, the entire system starts to depend on another infrastructure layer altogether. Naval bases, ports, and shipyards. Naval power is often measured in ships, submarines, and carrier groups. But those fleets only exist because of a fixed network of ports, stations, depots, and industrial yards that keep them supplied and seaworthy. A naval base is not just a parking place for ships. It is the shore-based infrastructure that allows maritime force to remain operational over long periods. At the simplest level, a naval station provides berthing, security, fuel, communications, logistics, and access to crews. But the deeper mechanics sit behind the pier. Warships require constant maintenance, weapons handling, specialized training, spare parts, dry dock access, and a steady flow of technical labor. The larger and more complex the vessel, the more important that support network becomes. A guided missile destroyer can deploy globally, but only because shipyards and naval facilities keep its propulsion, radar, electronics, and weapon systems functioning between operations. This is why the Navy separates functions across different installation types. A naval station may focus on fleet presence and embarkation. A naval shipyard is built around heavy repair, overhaul, and modernization. A submarine base adds another layer of security, technical servicing, and munitions control because undersea platforms operate under far tighter operational constraints. In other words, the fleet seen at sea is only the outward expression of a much larger industrial system on land. Norfolk is a clear example of that scale. It is widely recognized as one of the largest concentrations of naval power in the world, but its significance comes from integration. Piers, aviation facilities, logistics centers, and nearby repair infrastructure all work together to support sustained fleet operations. That is what allows naval forces to move from peacetime presence to crisis response without rebuilding the system from scratch. And that reveals an important truth about military basing. Some installations project power directly. Others regenerate it after use. Ships can leave port and operate far from shore, but eventually they return to a hidden framework of repair, rearming, and resupply. To make that possible across all services, the military depends on an even broader category of infrastructure: depots, arsenals, and logistics bases. The most important military installations are often the least visible. They do not launch fighters, sail carriers, or host parade formations. Instead, they keep the entire force supplied, repaired, and ready. Logistics bases, depots, and arsenals are where military power is turned from a temporary surge into a sustainable system. A depot exists to restore and maintain complex equipment over time. That can mean rebuilding aircraft engines, overhauling armored vehicles, repairing electronics, or extending the service life of aging platforms. This is not routine field maintenance. It is industrial-level work, often performed by a mix of military personnel, civilian specialists, and contractors with highly specific technical skills. Without that layer, equipment would wear out faster than it could be replaced. Arsenals and ammunition plants serve a parallel role. They manufacture, store, test, and distribute the materials that make combat systems usable in the first place. That includes everything from artillery rounds and missile components to small arms parts and propellants. These sites operate under strict safety, transportation, and security protocols because they sit at the intersection of industrial production and military readiness. The further a force is deployed from home, the more it depends on these fixed supply nodes operating without interruption. A useful way to see this is through long wars and extended deployments. During the wars in Iraq and Afghanistan, the United States did not sustain operations simply by rotating troops. It sustained them by continuously moving spare parts, fuel, munitions, replacement vehicles, and repaired equipment through a global support chain. That meant activity at ports, air hubs, storage centers, maintenance depots, and distribution bases thousands of miles from the battlefield. The front line depended on factories and warehouses as much as on tactical units. This layer of infrastructure explains why military readiness is not just about how many units exist on paper. It is about how quickly equipment can be restored, how safely munitions can be moved, and how efficiently supplies can be pushed through the system. And once those supplies begin crossing regions and theaters, another question becomes central. Who manages the web of command, communications, and coordination that ties all of these installations together? What makes a military installation truly strategic is not only what it stores or trains, it is how it connects into command. Bases do not operate as isolated properties. They sit inside a hierarchy of authorities, communications networks, and planning systems that determine who can move forces, allocate resources, and respond to crisis. At the local level, an installation has its own commander, support staff, and security apparatus. That leadership manages daily operations, housing, maintenance, access control, emergency response, training schedules, and the coordination of subordinate units. But the more important decisions usually sit above the base itself. A wing answers to a numbered air force. A fleet concentration area answers through naval chains of command. Army posts support corps, divisions, or higher headquarters. In other words, a base is both a place and an interface between local activity and national strategy. This is where command and control infrastructure becomes essential. Secure communications centers, operations rooms, intelligence support cells, and data networks allow installations to receive orders and translate them into movement. A deployment order is not just a message. It triggers a sequence involving transport scheduling, equipment issue, runway or port access, fuel allocation, force protection, and coordination with other bases along the route. The installation becomes a switching point in a larger operational circuit. Joint basing reflects this logic clearly. In the United States, some installations were merged under the base realignment and closure process to reduce duplication and concentrate support functions. The result was not simple administrative efficiency. It created platforms where multiple services could share logistics, infrastructure, and command support while still pursuing different missions. A joint base may host airlift, medical, administrative, and security functions at the same site, making it a coordination hub rather than a single service outpost. That matters because modern operations rarely stay within one branch. Moving an Army brigade may depend on Air Force transport, Navy sea lift, cyber support, and intelligence fusion from multiple commands. The base network therefore has to do more than hold forces. It has to synchronize them. And to do that effectively, the military depends on another kind of installation entirely: training centers and schools that standardize how people operate inside the system. A military base is not only where forces are housed, it is also where they are shaped. Training installations and service schools form the human operating system behind the hardware, turning recruits, specialists, and officers into people who can function inside a highly standardized institution. That process begins with basic training sites, which are designed less like ordinary bases and more like controlled transformation environments. Their purpose is to break civilian routines and replace them with military discipline, physical conditioning, procedural compliance, and collective identity. Every schedule, inspection, and drill is part of a system meant to produce predictability under stress. The goal is not just toughness, it is repeatability. From there, the structure becomes more specialized. Advanced individual training sites, technical schools, flight training centers, war colleges, and combat training centers each serve a different layer of the force. Some teach narrowly defined tasks such as aircraft maintenance, signals intelligence, or artillery fire direction. Others rehearse large-scale operations involving brigades, air wings, or joint task forces. A training base is therefore a place where doctrine is translated into human behavior. A good example is the National Training Center at Fort Irwin. It does not simply give units more time in the field. It simulates a realistic combat environment with opposing forces, electronic warfare, reconnaissance pressure, and logistical strain. Units are evaluated not just on firepower, but on how they communicate, move, resupply, and adapt under friction. The installation functions as a testing ground for institutional competence. That reveals an important point about the military basing system. Some installations store equipment, some project force. Training bases do something more foundational. They standardize performance across a vast organization. Without that standardization, command structures would become inconsistent and advanced systems would be used unevenly. But people do not train in a vacuum. The quality of that preparation increasingly depends on access to another layer of infrastructure. Research sites, testing ranges, laboratories, and technology-focused installations where new methods and systems are developed before they ever reach operational units. To understand how military bases shape future capability, it is necessary to look beyond barracks and runways and into the research and testing network. These installations do not exist mainly to house forces. They exist to refine weapons, validate concepts, and reduce uncertainty before a system reaches the field. Testing ranges are built for scale and control. They provide restricted airspace, instrumented land areas, ocean access, telemetry systems, and safety buffers that allow the military to evaluate missiles, aircraft sensors, electronic warfare tools, and integrated command systems. What matters is not only whether a platform works once, it is whether it works repeatedly, under measured conditions, against known variables, and eventually in more realistic operational scenarios. Research laboratories and development centers serve a related but different role. They connect military requirements to engineering, software, materials science, communications, and emerging technologies. Some focus on aviation and propulsion, others concentrate on naval systems, cyber defense, surveillance, or battlefield networking. These are the sites where doctrine starts influencing design. If commanders need longer range, greater survivability, or better data fusion, those demands eventually move through a base-linked ecosystem of scientists, contractors, acquisition officials, and test personnel. A useful example is Edwards Air Force Base, which became one of the most important flight test centers in the United States because it offered the space, infrastructure, and instrumentation needed to push aircraft beyond standard operational limits. Its importance was never just geographic, it was institutional. It linked experimental engineering to formal evaluation, and formal evaluation to procurement decisions that shape the wider force. This layer of the basing system matters because modern militaries depend on constant adaptation. A new radar, drone, missile defense interceptor, or encrypted network cannot simply be invented and distributed. It has to move through controlled environments where its performance, failure points, and logistical demands are understood. And once those systems are proven, another challenge begins. New technology only matters if it can be integrated into actual missions. That brings the focus to a different class of installation: intelligence, surveillance, communications, and cyber facilities that turn information into operational advantage. Modern military power depends as much on information architecture as on ships, aircraft, or armored units. That is why some of the most consequential military installations are not designed around visible combat platforms at all. They are built around collection, processing, secure communications, and decision support. These facilities take many forms. Some are intelligence campuses where analysts, linguists, planners, and technical specialists work inside compartmented systems. Others are surveillance sites tied to satellites, radar networks, signals collection, or airborne reconnaissance. Still others are cyber and communications hubs that protect networks, route data, and maintain the secure links connecting commanders to forces in the field. In each case, the installation exists to shorten the distance between raw information and usable action. The mechanics are complex, but the logic is simple. Information has to be gathered, verified, interpreted, and distributed before it becomes operationally useful. A radar warning site may detect activity, a signals unit may intercept communications, an intelligence center may fuse that with imagery, logistics data, and regional context. Only then can commanders decide whether an event is routine, deceptive, or strategically significant. The base in this case is not a launch point. It is a processing node inside a much larger sensing network. A clear historical shift can be seen after the Cold War, and especially after September 11th, when the military and intelligence system placed far greater emphasis on persistent surveillance, data fusion, and networked operations. Installations supporting drone operations, signals analysis, and real-time command links became more central because operations increasingly depended on seeing, tracking, and responding faster than the adversary. This matters because force projection without information is slow and uncertain. Aircraft can fly and ships can sail, but they are far more effective when linked to installations that continuously gather and interpret the battle space. In that sense, intelligence and cyber facilities are force multipliers anchored to fixed locations. But even the best information network has limits if forces cannot be positioned close enough to use it. That is where the next layer of the basing system comes into focus. Overseas bases, forward operating sites, and the geography of global access. A military base becomes strategically different the moment it sits outside national territory. Domestic installations generate, train, repair, and organize force. Overseas bases change the time and distance of response. They allow aircraft, ships, troops, and logistics to begin much closer to the point where they may actually be needed. That is why forward basing is less about symbolism than geometry. A carrier can cross oceans, and transport aircraft can bridge continents, but both consume time, fuel, maintenance, and political coordination. A network of foreign bases, rotational sites, and access agreements reduces those constraints. It gives planners more options for deterrence, crisis response, humanitarian relief, and regional reassurance without requiring the permanent movement of the entire force every time a contingency appears. These overseas locations vary widely. Some are large, enduring hubs with family housing, hospitals, repair capacity, and major headquarters functions. Others are austere facilities with prepositioned equipment, limited personnel, and the infrastructure needed to receive forces only when necessary. Still others operate through rotational presence rather than permanent basing, allowing the United States to maintain access while limiting political and financial costs. In structural terms, they all serve the same purpose: compressing deployment timelines and extending operational reach. A useful example is the role of bases in Germany, Japan, and South Korea after World War II and through the Cold War. Public debate often focused on alliance politics, but the operational reality was more concrete. These installations provided fixed logistics, command infrastructure, maintenance capacity, and regional staging points that could not be improvised during a crisis. Over time, they became part of a durable security architecture, linking local geography to global force posture. This layer of the base system matters because global power is not only about possessing capability, it is about positioning capability. A weapon or unit that exists only on paper inside the continental United States is different from one already tied into an overseas network. But forward presence creates its own demands. Once forces are stationed abroad, they become dependent on host nation politics, legal agreements, protection measures, and strategic vulnerability. That leads directly to the next question: how these bases are secured, defended, and kept resilient under threat. A military installation is only useful if it can survive disruption long enough to keep operating. That is why base defense is not a secondary concern added after construction. It is built into the structure of the installation itself, from perimeter design and air defense planning to backup power, dispersal procedures, and continuity protocols. Security begins at the most visible level with fences, gates, patrols, surveillance systems, restricted zones, and access control. But those measures only address routine threats. The more serious challenge is protecting a base against sabotage, cyber intrusion, missile attack, drone surveillance, supply interruption, and infrastructure failure. In modern planning, an installation is treated as both a support platform and a target. The larger its operational value, the more likely an adversary is to try to disable it indirectly rather than confront frontline forces first. This is why resilience has become such an important concept. A resilient base is designed to absorb disruption and continue functioning. That can mean hardened shelters for aircraft, redundant fuel and communication systems, alternative runways, distributed storage, protected command centers, and contingency plans for rapid repair. Naval facilities may disperse ships. Air bases may practice agile, combat employment, moving aircraft and support crews across multiple locations to avoid presenting a single fixed target. Ground installations may rely on layered force protection, backup logistics, and rapid mobilization protocols. The lesson became clearer as precision strike systems improved and low-cost drones spread more widely. A base that once seemed secure due to distance or size can now be monitored, targeted, or harassed in ways that were far less practical decades ago. Protection, therefore, depends less on a single barrier and more on an integrated defense posture, combining physical security, intelligence warning, cyber defense, deception, and recovery capacity. This matters because the basing network is a foundation, and foundations are attractive targets. If an adversary can delay sorties, damage fuel storage, jam communications, or disrupt port operations, the effects can spread well beyond one location. So the next layer of the story is not just protection, but concentration. How the military balances massive installations against smaller, more flexible sites across the wider network. For decades, military planners often favored concentration. Large installations were efficient. They simplified command, reduced duplication, centralized maintenance, and allowed huge numbers of personnel and equipment to be managed from a few powerful hubs. But efficiency creates exposure. The more capability packed into one place, the more attractive that place becomes as a target, and the more disruptive a single successful strike can be. This is the central tension in modern basing strategy: concentration versus distribution. A massive base can store more fuel, host more aircraft, support larger headquarters, and process more logistics than a small outpost. At the same time, it creates a dense signature that can be tracked, mapped, and threatened. A distributed network of smaller sites is harder to cripple all at once, but it is also harder to supply, coordinate, and defend consistently. The military increasingly has to balance both models rather than commit entirely to one. That balance appears across all services. The Air Force has explored more dispersed operating concepts, so aircraft can move across multiple locations instead of relying on a few main air bases. The Marine Corps has emphasized lighter, more mobile formations able to operate from less predictable positions, especially in maritime environments. The Army uses a mix of major permanent posts and smaller rotational or expeditionary sites depending on mission and theater. The Navy, meanwhile, still depends on large ports and shipyards, but also uses wider access networks, pre-positioning, and dispersed operations to reduce bottlenecks. A useful way to understand this shift is to see it as a response to range and precision. When adversaries can strike farther and identify targets faster, the old assumption that rear area bases are automatically safe becomes weaker. The question is no longer simply where to build the biggest installation. It is how to create a network that can remain functional even when parts of it are disrupted. That brings the analysis to the deepest level of the system. Bases are not just real estate and infrastructure. They are instruments of strategy. Their size, placement, and flexibility all reflect what the military believes future conflict will demand. And that sets up the final issue before the conclusion. What these installations reveal about national priorities, deterrence, and the future shape of military power. To see what military bases really represent, it helps to stop viewing them as isolated facilities and start viewing them as policy made physical. Every installation reflects a decision about what kind of power a state wants to maintain, where it expects risk to emerge, and how quickly it believes it may need to respond. That is why the basing network doubles as a map of national priorities. A large armored training post suggests long-term investment in ground combat readiness. A submarine support base signals commitment to sea-based deterrence. A remote radar or missile warning site reflects concern with early detection and strategic timing. Even a logistics depot reveals something important. It shows that endurance, not just firepower, is being treated as a core requirement. In that sense, bases are strategic documents written in concrete, steel, fuel lines, and command systems. They also shape deterrence in ways that are easy to miss. Deterrence is not only about possessing advanced weapons, it is about convincing others that those weapons can be generated, sustained, protected, and used on time. A visible overseas airbase can reassure allies and complicate an adversary's planning. A hardened naval support facility can signal staying power. A dispersed set of operating sites can suggest that disabling one location will not collapse the wider network. The installation itself becomes part of the message. This was visible throughout the post-1945 era, when basing arrangements became central to alliance systems, nuclear posture, maritime security, and rapid reinforcement planning. It remains true now, but with a different emphasis. Today, installations are being judged not only by size or permanence, but by survivability, interoperability, and adaptability. Can they support joint operations? Can they recover after disruption? Can they handle new domains such as cyber and space-enabled warfare? That is the strategic reality behind the map. Military bases are not simply where forces live. They are where doctrine, geography, logistics, and political intent are fused into something operational. And once all of those layers are visible, the final question is no longer what kinds of bases exist, but what kind of military system this network is ultimately designed to sustain in the decades ahead. In the end, the military base is not a backdrop to power. It is one of the main ways power is organized, stored, and made usable. The public usually sees the visible edge of the system: aircraft on a runway, ships at a pier, troops in formation, armored vehicles crossing a training range. But the real significance of the basing network lies in the invisible relationships between installations, missions, supply chains, command structures, and strategic geography. Taken together, these sites form a layered operating architecture. Major forts and camps generate ground forces. Air bases create reach and mobility. Naval stations and shipyards sustain maritime presence. Depots and arsenals keep equipment and munitions flowing. Training centers standardize performance. Research ranges refine future capability. Intelligence and cyber facilities turn data into decision-making. Overseas bases compress distance, while hardened and distributed sites try to preserve the whole network under pressure. Each category solves a different problem, but none functions fully on its own. That is why the most accurate way to think about a base is as part of a system of systems. A single installation may appear self-contained, yet its effectiveness depends on dozens of others. A fighter wing needs fuel pipelines, munitions storage, maintenance depots, intelligence support, and secure command links. A naval task force requires port infrastructure, industrial repair, communications, and pre-positioned logistics. Even the most elite unit is constrained by the quality of the installations behind it. Military capability, in other words, is never only about the platform or the personnel. It is about the infrastructure that keeps both available at the right moment. Looking ahead, that infrastructure will face a different set of pressures than it did in the past. Precision strike systems, drone surveillance, cyber disruption, space dependence, climate stress, and alliance politics all complicate how bases are built and defended. The future challenge is not simply expanding the network, it is making it more resilient, more flexible, and more distributed without losing efficiency. So the strategic reality is clear. Military bases are not just places where wars are prepared. They are the physical framework through which a state converts resources, technology, and geography into sustained military action. To understand the military system as a whole, this is where the analysis has to end, not with a single base, but with the network that makes all the others matter.